friendly interface, which is basically to do with infrastructure, your medical facilities, your basic health facilities, your education facilities and stuff like that. So when you look at these three goals of a smart city and you see the dependencies it has, ICT, I say, is still a very small component in this whole aspect. You cannot have just the ICT playing a role. You have a non-ICT, which is the renewable energy. How are you going to use the different forms of energy that is available to you? How you are going to do green buildings, how you are going to increase the norms in terms of creating the green buildings, the infrastructure associated with that. So that's a non-ICT play. And then there is of course the government initiatives from an urban planning, how well the infrastructure or the bridges are going to be laid up, what metro facilities will be available and stuff like that. So that's more of urban planning. So, and ICT has two major components within that particular stuff. One is to do with the connectivity aspect, where we saw the talk on Vodafone as well in the morning. The connectivity is a major piece in terms of an IoT deployment from a smart city perspective. You can have the best IoT infrastructure, but if that sensor is not going to talk at that particular point of time when it's really needed, the whole IoT can come down. Your city can literally come down if one of your IoT things can fail actually. So broadband, then the connectivity aspects is a major player in terms of the IoT. And then basically we look at actuators and sensors and the data analytics. So if you look at an IoT ecosystem, the actuators and sensors are the real data generators. Then it comes to a gateway, which we call it as an edge computing or edge gateway. Then it comes to the cloud, and then basically the data analytics part of it, and the visualization, which either happens through a web or through a mobile, which the consumer uses. So in this whole context, the broadband still plays, broadband or the connectivity plays a major important role. So if you see today actually the ways people are looking at to tackle that, of course there is a Digital India plan which is looking at making that broadband available to the remotest part of that. Satellite is going to make a major play. You have seen Airtel investment in OneWeb, so which is bringing up the satellite connectivity to the distance areas. People are talking about drones being used. Facebook is actually contemplating of using drones for the last mile connectivity so that it can actually make free internet across the places where it cannot, where the internet cannot reach. So this all basic infrastructure would be needed before these actual sensors and data can actually make a real sense in the IoT environment. Now looking at the whole architecture, so coming back of the use cases, the dependencies and stuff, if you look at an IoT architecture per se, it's actually not a pyramid architecture, nor it is an inverse pyramid architecture. We call it as an hourglass. So in which basically the platform is going to be provided at a central place, or a series of platforms that will be available in a central place, but the innovation is really going to happen at the bottom layer, which is your devices, sensors, actuators and gateways, and on the top, which will be going to be majorly applications that are going to be there. So instead of when you are actually designing an IoT, that's what we represent when we talk to the customers as well, we say don't worry about the application part of it actually, because the moment you try to solve an IoT problem with respect to a business case or an IoT like an enterprise, it actually falls apart because your architecture doesn't support a new applications of IoT coming on top. So we say you focus on the middle part, which is your platform, your architecture, your scale and things like that, and give that particular connectivity pieces where sensors can come and literally do a plug and play, and application providers can actually come on top of it, test their applications and innovate new ways of application. As long as the data is available, new applications can be derived from that. So that's what we talk about. So from a government perspective, I think the sharing of the data becomes very important. The ease of doing business and also the standards and policy from a privacy point of view, actually what standards needs to be actually maintained has to come in from the government. So that's the broad assistant. I think I was going to talk about the applications of IoT as well. The virtual personal assistant that you talked about, it's a big application from an ease point of view, a customer friendly point of view, and there are many different applications of IoT, but I thought I'll just cover the architecture point. So I'll leave it here, and we'll be happy to answer any question and answers later. Thank you very much.
Thank you, Mr. Agarwal. I now request Mr. Subrata Das, who is the country lead of IoT SA.
Good afternoon. I know I probably standing me and my next speaker between a very tiring day and welcome break. So I respect the time that you spend with us. And much of what I'm going to speak about today unfortunately has been, dealt upon ad infinitum, ad nauseum by previous speakers in terms of whether it's been slides or executive speak or even videos. So as you can see on the screen, there are quite a few number of slides that I intend to present today. But given the time constraint that we have and the responsibility that I carry to most of the people seated here, whom probably I have almost more than 18-20 years of relationship, and the very fact that SAP probably would be driving 80% of the businesses that matter here in this particular region, I think I have a responsibility in explaining what SAP especially does in the area of Internet of Things or everything, or whatever you call it. So I think the most important slide, I'm going to spend 2 slides in explaining what we do. First and foremost, where does SAP come in? And to that extent, explaining the IoT ecosystem once more probably wouldn't hurt. So as you can see, there are several players in this ecosystem. So there will be players who build sensors. Some of them would be intelligent sensors, meaning that they would have the capability of sensing what's happening, translate the inputs that they receive in a digitized format, and ability to transform that data into something which computers and other systems can understand. And then there is the communication backbone through which they will send the data, which is typically the internet protocol, but there could be other protocols as well. And as you would see, and there were other slides on Industry 4.0, the standards around the industrial automation and the new evolution in the industrial automation are just about evolving. So IP may not be the only communication protocol through which we communicate with the internet, with the sensors. So there would be other things that would evolve. So there are communication protocol and connectivity providers that will be there. And then there would be the standard players, the platform, servers, and the storage. And those technologies are also evolving because we are moving the compute away from the storage device into the memory. So there are severe efficiency benefits that people get. The way the storage technologies have been changing, the way the server compute capacities have been changing, there's a lot of development around that as well. And then there are several IoT applications that will get built based on the information that you receive from the edge of the network, based on the use case of the business problem that you're going to solve. There will be a plethora of applications which will be available, which you can partake of. And then what do you do with all the data that comes in? I mean, there are streaming data, there are unstructured information, and then you have the storage boxes where you store all of them. So what's the value differentiator? I think the value differentiator comes from being able to analyze that information and put it to use so that you can take better decisions. Protect property, save lives, increase your business, get into new markets, reimagine business models, as some of my last colleagues on the dais said. So, and then there are people who would probably put it all together, right from the sensors, then up to the insight and action, another word that was used. So I think in this entire value chain there will be multiple players, and not one single vendor will probably have the capability of delivering it all, because our core competencies in this particular domain also matter as to where we can drive the maximum amount of value. So instead of trying to address everything, we realized that this is an ecosystem which is large enough. I think some of the slides talked about 14.4 trillion being the global networked economy, which will be driven by Internet of Things going forward. And I take this figure from various research, from whether it's McKinsey, whether it is Baines, whether it is Beecham, whether it is Cisco. So based on that, we do realize that this business is big. So the canvas would be big for everybody to work in. So that, having set the premise there, I quickly move on to the next few slides. And this is the last slide that I'm going to have for the day, because I say that I have the responsibility of explaining the SAP IoT story there. Some of my customers who are here, who probably gone to the Sapphire at Florida, would have already been exposed to this slide, but suffice it to say that this slide, I think, communicates the strategy that SAP has in terms of Internet of Things. Being largely an applications company and moving up the gradient into somebody who is a technology service provider, first let me just dwell upon three products that we have. I'll explain what these products do by the problems that they solve. The connected logistics, SAP predictive maintenance and service, and the SAP connected manufacturing. These are the three horizontal applications that we have, which are based on IoT. And then the base of all this is our game-changing platform called HANA. So which happens to be our data repository, our big data analytics platform. Also today it powers the S4 HANA application suite that we have recently launched. On HANA we have the HANA Cloud Services platform. So apart from the data repository and the analytics engine, we've built certain IoT services, and this would be commercial available any moment. Now we said Q3, I think Q3 end 2015 to be the release of the HANA Cloud IoT platform. It's already, of course, GA'd in some form, because the spatial data services, the IoT services development kit, the device driver building kit, the data modeler, all these are already available. Because there are other protocols which are evolving over a period of time, we are also trying to get that into the box which will be available. So the development platform, we realize that we can't go and build every possible application in this industry. So there will be a lot of play for the SAP partner community, the ISVs, to build their applications. So that happens to be the HANA Cloud IoT platform. What we have right now is the HANA platform, which is available both on-premise as well as in the cloud. The IoT platform will largely be available on the cloud platform. Whether we will have a data center in India, whether we will not, is something that the business that we see will be driven by business impact. But more importantly, let me just give you a few use cases which will explain what these horizontal applications do first. The port of Hamburg Port Authority, is a riverine port, much like Calcutta actually. And one of their biggest plans for development is that they want to move from 10,000 tons per annum of cargo to about 25,000 tons per annum over a period of the next 5 years. And being a riverine port, they do not have the wherewithals to actually expand within the city of Hamburg, because there would be other consequential damages if that happens. So, and one of the key result areas which port authorities typically look at is the ship turnaround time. The time that it takes for the ship to come in, berth, get stevedored, new material goes up or comes down, and the ship goes back. So the turnaround time has to be significantly reduced. And there are about 450 such elements, including tracking operators, traffic management operators, warehouse providers, coffee vending machines, which actually come together to decide how fast a ship can come in and move out of the port. The problem that we had in Hamburg Port Authority was that there was no communication between all these 450 elements. So along with T-Systems, which is a partner, and Deutsche Telekom, we build this innovation with Hamburg Port Authority, by which we are able to put sensors, connect all these disparate elements, get the information, transfer information back to the service providers much in advance. Say for example, the truck comes out of its parking area, then goes on to the main highway. For some reason there is a hold up or an accident or some outage has happened, there is a huge traffic jam. It not only impacts the operations of the port, but it also impacts the operations of the city. But if I knew in advance that this is likely to happen, if I had an intelligent sensor which told me that there is an event which has happened, I should be able to relay it back to the trucking driver so that the truck driver could get the information. I could also tell him on the geospatial map that he carries on his device, on his dashboard, that you take the left arterial road and you move on to another parking area where a hot cup of coffee will be waiting for you, and then when things fall in place, you can again move out to your final destination. And there was tremendous amount of efficiencies and substantial benefits which were received by Hamburg Port Authority by putting sensors across major components, getting the information, analyzing it, and throwing it back to the 450 players. So connected logistics is a cloud solution now available commercially, and it's available mostly for port authorities, airport authorities, warehousing agencies, trucking and logistic companies. The next issue is that of predictive maintenance and service. And the example that I like to speak about here is Kieser compressors, which is a German compressor manufacturer, much like let's say a Voltas or a KSV pumps that we have in India. So most of these people typically sell the machines to the end customers. At certain point in time, Kieser compressors looked at their business and they said that let's rethink what we are doing with our customers and why our customers are actually paying us, and they started selling the outcome as a service. What is the outcome of a compressor manufacturer? Cold air, right? So if the quality of cold air, the amount of cubic space that I deliver cold air to, the amount of cooling that I achieve, the amount of dehumidification that I achieve in a particular area are the outcomes that my customer is looking at from a compressor manufacturer. Let's focus on the outcomes. So when they started focusing on the outcomes, came the issue of maintaining service levels, that I should be able to cool down so much cubic meters of space in so much amount of time. I should be able to provide that service 24/7, and I should measure the quality of air. I should measure the quality of air for amount of humidity, so on and so forth. So there are several outcomes that they looked at, and they built sensors for that, and they captured the data. Also, they captured the sensor data pertaining to the various sub-assemblies and components that made up the compressor, so that at any given point in time, if a particular component or constituent of that particular compressor was about to fail, or it had reached the end of its life cycle, they were able to predict it. The predictive models were not built by SAP. The predictive models were given to us by the customer, and we built those predictive models using the HANA data modeler as well as Lumira, and we delivered that on the HANA platform. And then we used the outcome as well as the result to link back to their asset management and predictive maintenance system, which actually coincidentally ran on SAP as well, and we connected both the ends, resulting in great value. So again, this application is available on the cloud and commercially available. The third area is that of connected manufacturing, and typically the co-innovation which spurred the development of connected manufacturing was Harley-Davidson. Previously it used to take, and I am acutely aware of the time that I have taken, previously it used to take about 21 days for Harley-Davidson to deliver a customized bike to its rider. in the US. It's still not available in India because it took me about 45 days to get the delivery of my bike from Harley Davidson India, but where in the US, where the manufacturing facilities in Memphis and other places are around the customer bases that they serve, the time taken has come down from 21 days to 6 hours, and the production time of each bike, which used to be around 6 hours, has come down to about 89 seconds. So what they typically did was they tried to predict that in the entire assembly line and the robotic arms which fit the various configurations, there are about 1300 configurations which are possible on a Harley Davidson bike. So if you are able to get the customer information then this robotic arms would go and fit these fittings across to your bike, and this typically comes at a certain stage in the assembly line. So there are several points of failure. So if you're able to predict, we could take proactive action and reduce the downtime that would be caused by some of the elements in the assembly line coming down. And lastly, the HANA platform. And when I talk about the HANA platform, I come back to India. We have got this SAP Co-Innovation Labs in Bangalore, which works with partners in building solutions on the HANA Cloud IoT platform and delivering solutions that actually improve people's lives, which is aligned to the corporate strategy that we have. And the first example that I would like to take, and there are 2 already approved co-innovations which have come out. There is a huge list which is coming out in the next tranche. But just to figure out and tell you, and much closer to the smart city example that you gave, is every year there's a huge amount of loss to property and lives because of the flooding that happens in the upper Gangetic basin and the Brahmaputra basin. It's common knowledge, everybody knows it. And in spite of knowing, every year there are crores and crores of money which is spent in recovering from the losses that these floods create. So if we had a mechanism by which we could understand the water levels in the rivers, the distributaries, the water reservoirs, dams, embankments, and we could build a hydrographic model through which we could predict what's going to happen if the water level rises here on this particular river. What would happen to how many cubic meters of water would be available in a particular dam, and if that many cusecs of water is available in that dam, whether it is going to breach the embankment, and if it breaches the embankment, then how long it will take for that water to come and inundate a particular village in a geographical area. All these models are already available. This is not rocket science. Hydrographic modeling and predictive modeling for floods is already available. But what was not available is for the sensor to transmit real-time information and a platform to take that real-time information, populate the models, come out with the predictive modeling exercises, and send information either through mobile phones or some other mechanism back to the people who needs to take a decision. So flood prediction and modeling was one particular example. The second one was this was with a partner called Altaria. And the second example and the second product which came out of the Co-Innovation Lab was on connected cars, but this time it was a passenger vehicle. It was with Ashok Leyland and Hinduja Tech, wherein we put the device onto the canvas of the truck. We collected the vehicle information, and through telematics we sent it up to HANA. We analyzed the information, built predictive models, understood various parameters that Hinduja Tech and Ashok Leyland were basically trying to capture in terms of the kilometers driven, in terms of the geographical spread, in terms of gear ratios, in terms of fuel consumption, in terms of driver behavior, speeding, so on and so forth, so that this information could be analyzed and sent back to the truck operators and the vehicle operators so that they could take preventive action. So with this I end. This is the architecture that we have for the HANA Cloud IoT platform, some of the innovation that I already talked about. That's about it. Thanks for bearing with me, and have a nice evening. Thank you.
Thank you, Mr. Das. Can I request Mr. Selva Kumar, General Manager, Vodafone, who are our main sponsors for the day today. Mr. Selva Kumar.